All right, so lesson 17. So connecting graphs and rational equations. All right, so last lesson we talked about, where asymptotes were and where points of discontinuity were and how to find them and create the graphs. This one's really more about solving, right? We're going to be able to actually, solve something like this because we have an equation at this point, right? This side is equal to this side. We've done this before. Really, remember how we did this if we're graphing would just be, we can make this side y1 and this side y2, right? Like we can actually just graph those. And it's that point of intersection is where the solution to this would be. But yeah, so just another take on that now with rational expressions. So here, let's do example 1. So it says determine the roots of the rational equation of that algebraically. So really what that means is we got to solve for x, right? So what's going to happen there? So what I'm going to do, I'm going to rewrite this a little bit different. I am going to write it with, well, let's do this. Let's take this whole term. I'm going to move it over there. I think just to set it up a little bit nicer to get going. You wouldn't have to, but that's what I'm going to do. So we're going to write this out as x minus 5 is what's left on the left side there, is equal to 6 over, sorry, negative, because it becomes minus on that side. So minus 6 x plus 2. Okay, so from that point, what I really am not a fan of here is the x plus 2, right? So I can get rid of that, and the way I get rid of that is by multiplying everything, the top of both sides, by x plus 2. Now, what would work is I could multiply this term by x plus 2 and that term by x plus 2. But that'd be a lot nicer if I just went like this and went, okay, all of that whole side multiplied by x plus 2, right? That would be the better way to write that probably. You get the same answer in the end either way, but all right, so now that I have that set up, those cancel. And I'm going to expand those. So we end up with x squared. Expand all of it there, yeah. X squared minus 3x minus 10 is equal to, and I still have negative 6 over there. All right, so now the way we're going to solve this, guys, I need to get everything on one side. So I'm going to bring the negative 6 over there, making it positive. So that's going to become x squared minus 3x, and then the negative 10 and the positive 6 now become negative 4 is equal to 0. And we set it up this way because now we can factor. So factoring that when we have the other side equal to 0, we can solve for it. So we'll say factoring that as x minus 4 and x plus 1 is equal to 0. So that would make our answers x is equal to 4 and x is equal to negative 1. So those should be our solutions. It's a good idea to check all the time. So we can try that out, right? If I put in 4 into my original equation, right, it should be equal to 0. So I can try that out and say, okay, is this true? So 4 plus 6 over 4 plus 2 minus 5 should be equal to 0. And if you put all that in, yes, it does in fact equal 0. So 0 does equal 0. So that worked out. And I can do the same thing for negative 1. So if I said negative 1 plus 6 over negative 1 plus 2 minus 5 should be equal to 0. And it does. You get the same thing. You get 0 equaling 0 in that case too. So that's also a solution. So in this case, they were both solutions. Now, this whole checking thing, it's still good to do, right? Because we can see, we know for sure we did everything correct too, right? Like I know that's the case. So I got this one right 100%. But really, it should only be the case that the numbers that don't work, the only number that wouldn't really work here would be that because of this, because of the dividing by 0 here. So if I ended up getting one of these answers down here as negative 2, well, I just know right away that can't be an answer because negative 2, I got a lot of lines going there, negative 2 is a non-permissible value, right? I'd have to say x cannot be equal to negative 2, right? That's a non-permissible value. Okay. But either way, it's a good strategy to check either way. And with one thing, remember with radicals, right, with taking square roots, there was a lot more ways that we could come out with a negative number, right, that would make it so it didn't work out. But with these, yeah, there's not as many ways that things can go wrong. So, all right. So next one says graph the above equation to check the answers from part A. So if you graph this thing, it would look I'm not going to get too in detail here, but you would see that you'd get a graph that crossed at 4 and -1, right? Those would be my solutions. And that's the way the graph would look. But technically, if I graph this thing, I also knew, like I said, that there was a non-permissible value at -2. So technically, this thing should have over at -2 here, right? That should be a hole, right? We should have a PO, point of discontinuity right there, right, on this graph. So yeah, the graph would look kind of funny too. It wouldn't be like as nice as, like, it's not just a straight parabola like that, but yeah, that's the general idea. All right, so same as before, sometimes we can't always get to this point, right, where it worked out nicely that we were able to factor it and set everything equal to 0 and then find our factors and solve that way. Sometimes they're not so nice. Sometimes we're going to get irrational numbers out of this. So we need to use our quadratic equation. So let's do this one. Okay, so we're going to factor the top. Well, actually, you know what? We'll do it. First, it says graphically. So in this case, what we're going to do, just in your graph, you would graph this as y1 and this part as y2. Okay, or f of x1 and f of x2, depending on the calculator you're using. But in the end there, you would get a graph that looked, and again, this won't be perfect by any means, but something like that and something like this. And that would be the y1 part of it, right? The red part here. So y1 would be equal to all this stuff up top, right? Here, I'm not even gonna write it, it's fine. It's just that's what y1 would be. And then y2 would be, well, this is just the equation of a line, right? So that would just crossing a -1, we'll cross down here and do something like that, right? So really what I'm looking for here for my solving this would be, where do these things cross, right? And if you find those, where they cross, like the x values where those cross, would be at x is equal to 3.1 and x is equal to -0.4. Right, those are those two x values, right? That x value there and that x value there would be those points. You could also find the point itself by plugging these numbers, right, back into those x values, right, to solve for the y for each of those. Okay, so you can do that. Now we're going to do it algebraically though. So let's start off with our original equation again there now. So we're going to have x squared minus 3x minus 7 over 3 minus 2x is equal to x minus 1. Okay, so very first thing, I'm not a big fan of the denominator, like having this down here. So I'm going to multiply both sides by that. So we're going to have 3 minus 2x canceling on this side, and we get 3 minus 2x on this side. So next line here, we've got x squared minus 3x minus 7 is equal to, expanding all of this out, you would get, here, I'll let you guys kind of get to this point, but you end up getting negative 2x squared plus 5x minus 3. That's just from doing FOIL with those and then collecting like terms after, right? All right, so now in this point, again, we've got x squared terms, x terms, and like a constant on the end. So the way we solve these is by getting everything on one side and equal to 0 on the other. So what I'm going to do, I'm going to do all these in one move. I'm going to go plus 2x squared on both sides. So plus 2x squared. I'm going to go minus 5x, and plus 3. So plus 3. So that just gets rid of everything, right? I'm just putting them all together nicely. So on the right side, we get 0. After adding all these up, we get 3x squared minus 8x minus 4. Okay. So now at this point, you could try to factor it and see if things work. It's not going to work. So what we're going to do, we're going to do the quadratic equation, right? So here is my A value. There's my B value. And there's my C value. All right. And the quadratic equation is X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. So we're just going to throw all those numbers in now. So let's go. So it's going to be X is equal to, so I'm just going to call this 8 because it's minus negative 8. So 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 4 all over 2 times 3. Putting all that in, we get X is equal to, doing the positive and then doing the negative, we get two answers out of this, right? 3.1, and we get X is equal to negative 0.4. So same as above, right? So it doesn't matter how you do it. This was the graphing way, and this was the algebra way. Okay, moving on. So solve this one algebraically. Okay, so this one will be a little bit tougher because there's 3 terms we got to deal with here. We did this a lot in 20-1. So see if this all makes sense. I'm just going to write it all out again. It's going to get kind of messy. So we'll go X over 2X plus 5 plus 2X is equal to 8X plus 15 over 4X plus 10. Okay. Actually, you know what? Just for the sake of time, I don't want to write all that over again. What I'm going to do, this 4X plus 10, sorry if you guys wrote that down. I'm going to factor that right now because something's going to happen that's going to make my life easier, right? So if I factored a 2 out of that one, right, I'm going to have 2 times 2X plus 5. All right, well, what happened there that makes my life a lot easier is this 2X plus 5 part, right? Because I have the same thing over there, 2X plus 5. So remember how we get rid of these things? What we do is we take the greatest common factor of both of these things, right? So I have to multiply. Really what the idea here is I want to multiply the top of each of these terms, that term, and that term, by something that's going to cancel out all the bottoms, right? So if I'm going to do that, if I'm going to cancel out, let's say, the bottom here, well, I'm going to have to multiply the top by, I'll put brackets here so we don't get confused. Multiply the top by, I don't need that bracket yet, 2 times 2X plus 5, right? So then all of that would cancel with the bottom. But I can't just multiply the top of this side by, of this term by 2 times 2X plus 5. Whatever I do to one term, I have to do to everything. So I'm actually going to do on this side too. So it'll be this one times 2 times 2X plus 5. And this side, 2 times 2X plus 5. Okay, so then at that point, I can go to town crossing things out that I'm able to. So I'm going to cross out all of that with the entire bottom there. The middle one, I can't cancel anything out. But the bottom one, I can cancel out the 2X plus 5 and the 2X plus 5, right? All right, so now we just write what we have left here. So I've still got the 2 and the X here, so that's going to be 2X plus, now just careful on this one because I got like 2X and then I got all that. This 2 and that 2, I'm just going to call that 4X. And I'll still just, for one more step, I'll write it out as 2X plus 5. I won't distribute it yet. You could, if you're okay with that, you could have. So, and then say is equal to. And then on this side, I've just got 8X plus 15. Okay, next line down. I'm just going to write this again. So 2X plus, and then I'll distribute it here now. So we're going to have 8X squared. All right, just distributing that in. And then plus 20X is equal to 8X plus 15. Okay, so now the same thing. I've got X squared terms and X squareds, or and X's. So all I can do is get everything over to one side. So let's get everything over to one side, have 0 on the other. So I'm going to subtract 8x from and 15 at the same time, right? We'll just to make my life easy. Okay. Actually, you know what? Let's do one more step just so we don't get lost here. Let's combine this one and this one. So we're going to have 8x squared plus 22x is equal to 8x plus 15. And now I'm going to subtract 8x and I'll subtract 15 at the same time. So let's go minus 8x. And this would have been like 0. Like I'd say this like plus 0, right? Minus 15. So on this side, we get 8x squared plus 14x minus 15 is equal to 0. All right, so now at this point, we could use the quadratic equation, right? That should work and you should get the answers out. Like I know some people just like that because you just plug the formulas in or plug it into the formula and you get it. The other thing we could do here is we can factor this. This one actually is factorable. So I'll factor this one just for good measure here. The way we factor these ones with a number out front, it's not as pretty. It's going to be bigger numbers, but we want to find a number that goes into, well, whatever 8 and 15 multiply to, right? So we're looking for numbers that multiply. So I'll say multiply to negative 120. And we're looking for numbers that add to 14, right? So add to the middle one. All right, so numbers that do that, if you search around a little bit, we end up getting negative 6 and 20, right? Those are our two numbers. So the way I'm doing this with these ones, right, when the A value isn't 1, we do it a little bit different. What I'm going to do is I'm going to take these two numbers and I'm going to rewrite the 14 with those two numbers. So writing this out, we're going to get 8x squared and then minus 6x plus 20x, just those two numbers, minus 15 is equal to 0. And then we're going to factor by grouping. So what we're going to do now is we're going to factor what we can out of those and then factor what we can out of those. So we're going to have 2x and then you still have 4x minus 3. And then on the next one, I'm going to factor out a 5. So we're going to have, and it's going to be a positive 5. So I'll say plus 5. And then you've got 4x minus 3, which is perfect because those ones showed up being this exact same thing. So that's one of our factors, right? And the other factor was the 2x plus 5. So here's what our factors were. We had, right over here a little bit, 2x plus 5 times 4x minus 3 is equal to 0. All right, so from here, it's not quite as obvious again, right? So now I can see from here, looking at this one, we can make our own little equation out of this, right? I know that I want to say, okay, 2x plus 5, I want to say, what is x to make this 0? So I'll make myself a little equation, right? So 2x plus 5 is equal to 0. So I'm going to subtract 5 from both sides, so minus 5, 2x is equal to negative 5. So then x is equal to negative 5 over 2. So there's one of my answers. And I'll do the same for the other one, right? Maybe you can do this one in your head. You're going to end up getting x is equal to 3 over 4. All right, so there's my two answers, right? But remember our non-permissible values. So at the beginning here, looking at our original equation, there and there, right? Because when you factor it, you can see it more clearly, the 2x plus 5. I'm not allowed to divide by 0. So x, right off the beginning, was not allowed to be negative 5 over 2, right? If you did the same, pretty much the same thing we did down there. So that's a non-permissible value. So that's not an answer. That's not allowed, right? Like I know that right off the bat that can't be an answer. You could put that back in, right, and try it out, and it won't work out. It'll work out as like an error. Yeah. So in the end here, we'll just say x is equal to 3 over 4, and that would be the only correct answer there. So careful for those on the questions, right, where you might think that you've solved it. You need to check whether or not it's actually an answer. Okay. verify your answer graphically. So graphically, this thing, nope, doesn't like that. All right. Would be, well, you get some, yeah, funny looking graphs here again. So this one, you have one that kind of does this and this, and the other one goes up and around, and they cross right there. And that actually ends up being the only place that they cross. And this will make sense because this answer right there should be at the point x is equal to 3/4. And it is. You end up, like, if you put that in your calculator, you should get the point 0.75 comma 1.62. So that 0.75, that's our x value from up here, right? That's 3/4. So that one and that one are the same. All right. Last one. This one's not too bad. It's just setting up the equation, actually. All right, so it says, in basketball, the player's free throw percentage is given by dividing the total number of successful free throw baskets by the total number of attempts. So far this year, Larry has attempted 19 free throws and has been successful on 12 of them. If he is successful on every attempt from now on, how many more free throws does he need to attempt before his free throw percentage is 80%? All right, so to figure out your average here, like what we're going to do, like they even told us in the question, that it's going to be the number of successes over the number of attempted, right? So in that case, our successes without the extra throws would have just been 12 over 19, right? That would have been, like it tells us there, you get the percentage, the free throw percentage, right? Would have been 12 over 19. And that would have been it. But they told us that he keeps throwing and he keeps making them, right? So that's where our like variable comes in. That's where the x value is going to come in. So it'd be 12 plus x, right? Where x is all the new throws. And you'd have that on the top, but you'd also have that on the bottom. It'd be 19 plus x, right? He's adding on the bottom, like more and more attempts that he's doing, one every time. And on the top, he's making every one. So it's the same number, right? So it's x over x. So there's our rational expression. Now, to make it our rational equation, right, we actually have a number that we want it to be, right? It's supposed to be 80%. Well, the only useful way to write a percentage, right, like especially in math and physics, and science in general, typically if you're doing calculations, don't like it as a percentage. We're going to rewrite that as 0.80 if you like, right? So that's 80%, right? Just as a decimal. That's equal to, and then our expression. So 12 plus x over 19 plus x. Okay, so now from that point, we could do this algebraically, or you could do it graphing. So if you're doing algebraically, you just, well, you know what? I'll just do it this time just by graphing, just because I did it already. I think you guys will be fine with this one at this point. So we'll say, okay, this is, you could graph this one as y1, and you could graph this one as y2. And then your graph, when you did that, would look something like this. I think it goes up like, yeah, it does something kind of funny there, but maybe something like that. And this would be like your y2, like maybe this is all you could see. You should have one at like a non-permissible value at -19, but we won't worry too much because the only place they cross would be, you should have like another line doing this. And that line right here would be at the y1, right? This point right here would be 0.8, right? That's like a straight line because I get that right? Yeah, y1, right? y1 is equal to 0.8. That's just a straight line, right? That's just that straight line. And then it's just where they cross is going to be your answer there. And in the end, that line would be at 16, comma, 0.8. And that makes sense that 0.8 is our y value, right? Because it crossed at that point on that line. So in the end here, 16, right? Our x value would be 16 there. And that's what it was asking for. It says, how many more free throws will he need to make? So he'll need to make 16 more. Okay. And that should be it.